at home. Okay, so I think we have completed the first law of application of first law of thermodynamics in the different process. Okay, so different process means we have completed the cyclic process, isolated system. What is how can we apply the first law of thermodynamics in the isolated system, and also isobaric process also we have discussed, as well as the isochoric process, as well as the isothermal process. Okay, so I want to ask some question first. How can you apply the first law of thermodynamics in the particular isolated system? How can you apply the first law of thermodynamics in the particular isolated system? In the isolated system, how can you apply the first law of thermodynamics? Who can raise? They can raise your hand, their hand if they are knowing their answer. Yes, anyone? Aisa Raina. Yes, Priyanka Sharma. Ram Thomas. How can you apply the first law of thermodynamics in the particular isolated system?
Internal energy is constant
Internal
because
energy is
work
constant.
are isolated or
Yes,
isothermal.
isolated system. How can you apply the first law of thermodynamics? First, tell me what is the first law of thermodynamics?
Sir, when
Yes,
sir, first law of thermodynamics states that when any amount of heat energy is applied to a system,
yes.
then along with the work done, there is also an increase in the internal energy.
Along the work done.
There
Just
is an
repeat once
increase in
again.
the
Just
there is
repeat
also the
once again
increase
what
in
you
the
are telling.
internal energy. When
Yes,
amount of heat energy is given
yes,
to a system, then
yes,
along with the work done,
yes.
the part of the heat energy is also used in increasing the internal energy.
Energy formula. What is the formula?
Sir, Q equal to delta U plus W.
Delta U plus W. So how can you apply the first law of thermodynamics in the isolated system? In the isolated system, first, what is isolated system?
Sir, in which no work, I mean, heat energy cannot, it is not in the connected with the surrounding. The system not connected with the surrounding.
Okay, that means whatever the heat energy we are supplying, that will not enter inside the system. Yes or no? So that means Q equal to zero. If Q equal to zero, W equal to also will be zero. So that means the internal energy will not change. It will be also near equal to zero. Okay. So this is the isolated system. How can we apply the first law of thermodynamics? Next question: how can we apply the first law of thermodynamics in the isochoric process? Okay, Ram, you just unmute yourself. Okay, next, Shreyans, class 11th, ID number 8801. Yes, you just tell me. This type of question will come compulsory, come in the exam. What is the first law of thermodynamics and how can you apply the first law of thermodynamics in a different process? 2 marks question or 3 marks question it will come. So first Shreyans, yes, class 11th A, 8801 ID number. Okay, one other Shreyans is there, 8814. You just unmute yourself.
Yes, sir.
Yes. Tell me, how can you apply the first law of thermodynamics in the isochoric process?
In the isochoric process, there will be
What is
volume.
first? Tell me, what is isochoric process?
Volume remains constant.
Volume remains constant. If the in this particular process, if the process is carried out through a constant volume, then this process is called as the isochoric process. Okay. So tell me, how can you apply the first law of thermodynamics?
In the isochoric process, the volume will remain constant.
Yes.
So the work done according to the formula P is into delta V is equal to 0.
Okay.
So the work done will be means Q will be equal to change in internal energy.
Okay, whatever the heat we have supplying, that will be used to only the increase the internal energy. That means Q equal to delta U. Okay. So we have completed. Okay, that means you are just reading at whatever the topic that they covering. Okay. Next question. Shreya Shukla is not there. Shreyans Pandey, Anushka. Okay, Anushka, just tell me, how can you apply the first law of thermodynamics in the isothermal process? Okay, Kritika. Kritika, you just tell me, how can you apply the first law of thermodynamics in the isothermal process? Isothermal. Whatever the topic that I completed, just read the topic once again, okay, at the home. Okay. So then it comes to adiabatic process. Last topic we have just left, that is called the adiabatic process. Adiabatic process. Okay. So in this particular adiabatic process, what is, first of all, we have to know the definition of adiabatic process. Definition says that if during a process takes place in the system, neither heat energy enters through a system or leaves from the system. That means whatever the heat energy inside the system, that will remain constant. That will remain constant. This process is called as the adiabatic process. This particular process is called as the adiabatic process. Adiabatic process, I'm again telling, this means say delta Q or Q, whatever the heat energy that we are supplying, that will be also zero. Okay. So that means say whatever the heat energy we are supplying, that will be zero. Okay. So in the process, if it is carried out, then this process called as the adiabatic process. This process called as which process? Adiabatic process. Okay. So how can you apply the first law of thermodynamics? First law of thermodynamics tells that Q equal to delta U plus W. Okay. So if Q equal to 0, then what will happen? Delta U plus W. Is or no? So delta, that means say W equal to minus delta U. W equal to, what will happen? W equal to minus delta U, or you can write it delta U equal to minus W. Delta U equal to minus of W. Okay. So that means here in an adiabatic process, work is, that means how the work is the negative. The two conditions are there. If work is done by the system, so it will be positive. Okay. If work is done by the system, then the sign will be taken positive. Remember this particular point. If work is done by the system, okay, and if the work is done on the system, then work will be, W will be negative sign will be given. Okay. Then we have learned about the heat also. If heat energy is given to the system, from the surrounding to the system it is given, then it will be positive or negative. If heat energy is given to the system from the surrounding, then it will be positive or negative. Yes, anyone can reply. If heat energy is given from the surrounding to the system, it will be taken as positive, or sign will be taken as positive or negative. Yes, Shivans.
Sir, positive.
Positive. And if it will be from the system to the surrounding, if it is released, then it will be taken as
Negative.
negative. Okay, thank you so much. So that means here work done will be that means a negative. So if you just put the first law of thermodynamics, that means just to put the formula, that means delta U equal to so you just put the formula Q equal to what? Delta U plus W. Okay. So delta U equal to Q minus W. Yes or no? So if the work done will be negative, so negative of negative 1, so it will be Q equal to 0, so 0 minus of minus W, so it will be also positive. Okay. So delta U will be positive. That means delta U equal to W. Okay. And if, and thus the internal energy of the system will increases if the work is done by the system. If work is done by the system, then delta U equal to minus W, and if the work is done on the system, in that particular condition, delta U equal to W. Okay, two conditions are there. First condition, if the work is done on the system, then delta U equal to what? That will be equal to W. And if the work is done by the system, that means the work is positive, then delta U equal to minus of W. Okay. Then we'll do some numerical related to the particular topic. Just write down question. When a gas undergoes a change of adiabatically, when a gas undergoes a change adiabatically from an equilibrium, from an when a gas undergoes a change adiabatically Adiabatically means Q remain constant, delta Q remain constant. Okay, whatever the heat that is inside the system, that will remain constant. So when a gas undergoes a change adiabatically from an equilibrium state A to another equilibrium state B, from a equilibrium state of A to the equilibrium state B, okay, then question in the question it is given 22.3 joule of work, 22.3 joule of work, 22.3 joule. Okay, so 22.3 joule of work is done on the gas. On the gas means work is done negative here. Okay, we have to consider work done is negative. So now in this particular question also one question given. Now if the gas is taken from system A to system B through a process in which the 9.35 calorie of heat is absorbed by the gas. Okay, if 9.35 calorie of heat is absorbed by the gas, then find out the how much work is done by the gas. You have to find out. You have to find out then how much work is done by the particular gas. Okay, and you know that already 1 calorie equal to how much joule? 4.18 joule. Okay, so you just put this relation and find out then the work done. What will the work done by the gas if the gas is to be changed from A to B and the in which 9.35 calorie of heat is absorbed by the gas. 9.35 calorie of heat is absorbed by the gas, then what will be the value of what work done? Okay, I'm just doing it. Okay, so first let me complete, then after I will ask another question, you will solve it. So in this particular question, what is given? You know that the first law of thermodynamics, that means Q equal to what? Delta U plus W. This relation you have known from the first law of thermodynamics. From the first law of thermodynamics, you have known that Q equal to delta U plus W. In the first sentence, what is given? That means it is adiabatically the gas will be changed from that gas undergoes the change adiabatically. Adiabatically means Q equal to 0. Yes or no? So Q equal to 0. What are the given things it is there? Q equal to 0 and and the work is done on the gas. That means work is how much? 22.3 joule. Okay, so that means W equal to minus sign. That means you have to put the negative sign here. W equal to minus of 22.3 joule. Okay, so minus 22.3. If it is the question, in the question it is given work is done on the gas, so we have to just written W equal to minus 22.3 joule. Okay, and you have to find out the what delta U. Delta U means what is the formula of delta? Delta U equal to Q minus W. Yes or no? So Q means 0 minus W. W means how much? Minus 22.3. So it will be plus 22.3. Minus of minus plus sign. So it will be 22.3 joule. So it will be what? Delta U. Delta U we have find out delta U equal to what? 22.3 joule. Okay. Then in the particular same question, one condition is given. Now the gas is to be taken from A to B through a process of in which the 9.35 calorie of heat. That means Q how much is given? Q is given in this particular question. Q is given 9.35 calorie. Calorie means so we have to convert it into what? Joule. So 4.18 you just multiply 9.35 into 4.18, it will be nearly equal to 39.1 joule. 39.1 joule. Okay. So you have to question is asking find out the W. W means the work done. If it is changing the what if so in the question you see that 9.35 calorie of heat is absorbed by the gas, then what will be the work done by the gas? Then what will be the work done by the gas? Okay, so that means W equal to what? What is the formula? W equal to, how can you find out the W? W equal to what? Q minus delta U. Yes or no? W equal to what? Q minus delta U. So Q means what is given? 39.1. 39.1 minus delta U, already you have find out. How much delta U will be? 22.3. You just subtract it. You will get the what value? That will be 16.8 joule. Okay, so this is the work done by the gas. If the gas is to be what the 9.35 calorie of heat is given absorbed by the gas, then what is the work done by the gas? The work done will be what? 16.8 joule. Okay, so next question, write down an electric heater. If this question is for you, that means you have to solve this question. Okay, an electric heater supplies heat to a system. Electric heater supplies heat to the system, okay, at a rate of 100 watt. At a rate of 100 watt. Okay, so the system performs a work at a rate of 75 joule per second. The system performs a work at a rate of 75 joule per second. This is a NCERT question. 75 joule per second. Okay, work done it is given, as well as the heat supply also it is given. The q is equal to 100 watt, it is also given. Okay, so at what rate, question is asking, at what rate the internal energy will increase? So that means a question is asking you have to find out the delta u. Question is asking it, you have to find out the delta u. That means it contains 2 marks question it is, but you have to find out the delta u here. Again, I am repeating the question. Electric heater supplies the heat to the system at a rate of 100 watt. Okay, and the system performs a work at a rate of 75 joule per second. Okay, 75 joule per second. At what rate the internal energy will increase? Yes, Shivans, Shreyans also, both. Shreyans, you just tell me the answer. Yes, Shreyans.
Good morning, sir.
Yes, yes. Good morning,
So
Vita.
the answer will be 25 watt.
25.
Watt.
Okay, explain it. The procedure. What the procedure you are just following? Just explain it.
So we will first of all we'll use the first law of thermodynamics, that
Yes.
delta U is equal to Q minus W,
Okay.
where Q is the heat taken by the system and W is the work done.
Okay. Okay.
And you have said that Q is 100 watts
Okay.
and Joule is W is 75 joules. So
Okay.
I have
Okay.
used that first law of thermodynamics formula and I've taken out that
Okay. Delta U equal to 100 watt minus 75 watt.
25
It
watt
will be
equal to
25.
25.
Okay. Thank you, Vita, so much. Okay. Okay. So this type of this is the second question. Okay. Write down the third question. Next question, how much maximum work can be obtained? How much maximum work? Okay, Ron, also you have the same answer. No, different answer you have got.
Sir, I have one doubt.
Yes, tell me.
Sir, in the
Yes.
isothermal process,
Isothermal.
sir, temperature is constant.
Yes, yes.
So internal energy is no change, sir. But internal energy also depends on volume,
Yes.
sir. So how here that
Internal energy, if the temperature will remain constant, temperature means if the body does not acquire any temperature, okay, whatever the temperature of the system, that will remain constant. So whatever the molecule inside the gas, that will also remain, that will no change in the what internal energy, I think. Okay, so if the temperature will remain constant, there will be no change in the internal energy. That does
sir,
not
my
depends upon the volume. Okay, so if the temperature will increase, then if the temperature in the will increase, then after the whatever the molecule of the gases are there, they will start but expanding, or they will start heating up. Then after the internal energy will change. Okay.
sir, if a system is provided 50 degrees Celsius at a
Yes.
constant rate without increasing temperature,
Yes. Yes.
then
Let's repeat the sentence.
sir, if a system is provided 50 degrees Celsius
50
at a
degrees
constant
Celsius.
rate,
Okay, at a constant rate.
sir, not change in temperature, sir, then if any material, water is taken, fluid is taken, sir, so there will be some change in its volume, sir, or gas is taken then also.
So you are just telling the question, or any was just giving the any
No, sir,
sentence?
I am telling you, sir, that this happens. So if a gas is taken at 50 and temperature is 50, then there will be a little bit change in its volume. Sir, so then
volume will
internal,
change. I'm not telling that the volume will not change, but our concept is that the internal energy will not change. Okay,
sir,
that
but
means
how the
if the
volume will
system is
change and
acquiring some
internal?
temperature, if the system is acquiring some temperature, then after you just see that the internal energy will change as well as the volume will also change. That means you just remember one relation. That means that is the Boyle's law. At Boyle's law, you just see that pressure is inversely proportional to volume. Just chemistry, you have read about the Boyle's
Yes,
law,
sir.
yes or no?
Yes,
So
sir.
what the Boyle's law tells that at
Uh,
constant temperature, pressure will be inversely proportional to the volume, yes or no?
volume.
So if
Yes,
the
sir.
pressure, you just apply the pressure, that means the gas will acquire some pressure, then it will also the volume. That means volume will be if you just increase the volume, then pressure will also decrease. So at a constant temperature, there is a relation between pressure and volume. That means the volume can change or pressure can change also. Okay, but our aim is to, that means if you just apply the first law of thermodynamics, in that condition delta U remain constant. At the process of isothermal process, delta U will not be changed, it will be equal to 0. Okay, in this particular what isothermal process, what will happen? Delta U equal to 0. So if delta U equal to 0, then whatever the heat we have supplying, that will be what? Delta U plus W. Okay, so if temperature will remain constant till delta U, that will be no change in the internal energy. Internal energy means whatever the particle inside the system, whatever the molecules inside the system, what are the gases inside the system, there will be no change in the internal energy. Internal energy means there will be no change, increase in the energy. Okay, so that means it will be 0. So only work done, whatever the heat we have supplying, that will be directly converted into work done. And work done, you already know that work done means what? PdV. Work done means what? PdV. PdV means pressure into change in volume. So that means dV will automatically change. Okay, if you're just giving this what heat to a system, obviously it will be what? Directly equal to PdV. W means what? PdV. So pressure and volume will be automatically changed, but there is no change in the internal energy. Okay,